is representing a data center. So representing machines connected to switches, machines located in racks, machines having applications on it, having network interfaces with certain ports open, et cetera, et cetera, et cetera. And I will show you that in a pretty graph. So this is saying call db.schema. Basically, it looks through your graph and decides how, what all different types of nodes, what are the labels. It looks at what all the different types of relationships are and how they can connect. And so in this case here, like services are actually connected to other services. That's what you're seeing, sort of that self-reference there. Machines have types. Machines are held in racks, etc. The one thing that you will notice here is sort of the use of the English language, like I mentioned earlier, of nouns, verbs, adjectives, adverbs. You really should be able to read through the graph. That's one of the most awesome things about a graph is that someone can actually give you a graph and you can just sit down and read through it. And pretty much, I mean, you're not gonna understand everything, of course, but a lot more than you'll understand if someone gives you an ER diagram, or at least in my experience. And so we're just seeing here basically we have racks, we have switches that are in those racks, interfaces on the switches, egress points, etc. And the guide here really guides you through some of the key use cases around what would happen if your data was represented for your network in a graph. And let's see here. Dependency analysis is one of the key ones here. And this particular query, basically, we're looking for, zoom up. So if you can read this, at the top here, we have let's see, something depends on a particular version. The software has that particular version. The software is Neo4j. That we have a machine which runs that software, or that software process, which is an instance of that service. The software process depends on a certain version of a Neo4j and an instance there on that Neo4j version. And we have the machine which runs the Neo4j process. And let's see if I go down here. So basically the goal of this is to figure out all of the different software that uses Neo4j within this data center, and we come up with something like this. And Neo4j does this awesome thing of like auto-connecting the relationships here. So we have this particular node here represents our CRM system, and our CRM system has a bunch of different machines that run it, that are instances of that CRM. And we can see here that those instances are running on particular machines, and they are depending on, the CRM depends on, in this case, a particular process. Neo4j 3.1 is a version number. And really just kind of looking at how all of the dependencies interact on your network allows you to do things and say, hey, I'm going to take down this particular SAN switch this Friday. What are all of the things that are going to be impacted when you take down this particular SAN switch? Let's look at those applications, and then if you're storing, for instance, your corporate directory in there as well, and the users of each of these systems, you can go ahead and actually notify the users of the outage rather than playing the telephone game of notifying, the sysadmin notifies the other sysadmins, or actually network admin notifies the sysadmin, notifies the other sysadmin, notifies the help desk notifies whatever. Like there's often that telephone game that goes on. And if you store the data in the form of a graph, it's actually quite easy to then query and figure out, here are the users that are going to be impacted by this outage and notify them. Similarly, if you take like a help desk system, and that help desk system notices there are these 6 things that are out right now. We've gotten calls, we're gotten alerts about these 6 things that are out. You can do root cause analysis on the network to say, what are the different components that these 6 things have in common? And you can take subsets. There might just be, one random thing that's out that's not caused by the same thing. But looking at sort of that root cause analysis allows you to kind of faster identify issues in your network. There are also some awesome open source tools built upon these ideas. The Lending Club folks created something called MacGyver for managing all of their microservices and the dependencies and relationships between those microservices. Cool thing to check out if you're running a network.